Okay, we're going to do a little, and this is 6.9, we're going to do a little more complicated absolute value equations, okay? I'm going to use 4 boxes for each problem, okay? We have 5, absolute value x plus 2 equals 25. Now, you put a times dot, but you do not distribute. That's for parentheses. This is not a parentheses. It's an absolute value, okay? So with an absolute value, okay, you go x plus 2 equals, x plus 2 equals, but you can't put 25 and negative 25 because what about the 5, okay? Well, I can't distribute, but one way I can get rid of 5 times 5 is underline both sides, place 5 underneath both of them, and those cancel. Now I have the absolute value x plus 2, and then 25 divided by 5 is 5. Okay. By the way, this 5 here is known as an A value. Okay. So if it's an A value, you divide. Okay. Divide to get rid of it. So where can you be to be 5 from 0? Well, I can be at positive 5 or negative 5. So 5, negative 5. Absolute value is 1 minus 2. 1 dot x equals 3. Then divide by your 1. 3 divided by 1 is 3. Okay. And over here, minus 2. Now it's negative 5 minus 2, so it's negative 5 backwards 2. It's going to be negative 7. Divide by 1. That's negative 7. So those are the 2 solutions for x. Okay, and in my next problem, the absolute value of negative 2x plus 1 plus 3 equals 17. Remember, you're not inside the absolute value, okay? One thing you might want to do, make a wall on the side of the absolute value and then make kind of a dash line where your absolute value begins and ends. So I got the expression negative 2x plus 1. But I can't put 17 and negative 17 because then I'm forgetting about the plus 3. Okay, if it's after the absolute value with a plus or a minus, it's known as a k value. The k values you get to 0. So how do you get from 3 to 0? You'd minus 3. Now go to the other side of the equation and minus 3 from that. So we have 14. 17 minus 3. And the absolute value of negative 2x plus 1. Okay. Okay, now I'm good. I can go 14 and negative 14. So if you have some kind of operation outside your absolute value, whether it be an A, which you divide, or a K, which you add or subtract, you need to deal with that before you go to your table. So dot circle, you get rid of your plus 1 by minus 1. So it's 13, negative 2 dot x. Negative 2 times what number is 13? Well, if I divide by negative 2, I'll know. X equals 13 divided by negative 2 is negative 6.5. Okay, so I got times plus 1, so I'm minus 1, but now I'm at negative 14. So if I was at negative 14 and moved backwards 1, that would be negative 15. Negative 2 times what's negative 15? Well, I divide. Negative 15 divided by negative 2 is 7.5 positive. Okay, and those are your 2 solutions. Okay, 3. Absolute value 5y minus 7, y is like an x, minus 6 equals 24. Okay, so inside the absolute value, I have 5y minus 7. But I don't know what it's equal to because I have operations on the outside. This is an A value, and this right here is a K value. Make it plus negative. Now when you have an A and a K, you need to do the K first and then the A second. Always, you can't flip them. So I get the negative 6 to 0 by adding 6. That takes us to 30 on that side, but I've still got 3 dot absolute value 5y minus 7. I've still got my a value. A values I do not distribute, you divide. Okay, underline each side and place a 3 underneath. Okay, now I have the absolute value of 5y minus 7. 30 divided by 3 is 10. Okay, so to have an absolute value of 10, you could be at 10 or negative 10. Okay, make your wall, dot circle. It's negative 7. So negative 7 to 0, I plus 7, plus 7. So I got 5 times y. This is 10 plus 7, 17. Then 5 times what's 17? Well, I'm going to divide by 5 and find out. 17 divided by 5 is 3.4. Okay, then over here, dot circle, that's a negative 7, so let's add 7. This time it's negative 10 plus 7, so I wouldn't start at 10, I'd go to negative 10. And then plus 7 moves forward 1, 2, 3, 4, 5, 6, 7. It'd be negative 3. Then I divide each side by the 5. Negative 3 divided by 5 is negative 0.6. Okay, that's what I have. Okay, next problem. The absolute value of 2d, and then the absolute value ends plus 3 equals 1. So inside the absolute value we have 2d. Okay, but I do have the plus 3. When it's afterwards, it's known as a k value. Okay, you have to get the k value to 0 by adding or subtracting. So it's positive, I'm going to subtract it. There's no a value. So 1 minus 3 is negative 2. Absolute value 2d. Well, we have a little problem. Absolute value in the end cannot equal a negative. You don't go negative 2, positive 2. It's got to be positive 2 then negative 2. So that's a no solution, because you cannot have a distance of negative 2. Remember, negative 2 is the distance from 0. You don't count by negatives when measuring distance. You got to watch out for that. Okay, next problem. Negative 3, absolute value x plus 4 minus 2 equals 16. Okay, so in the absolute value, I know what to put on my table. It's going to be the expression x plus 4. Now, I don't know what the absolute value is because I have two numbers out here. This times is known as a. This minus 2 or plus negative 2 is known as k. We get rid of the k first, then the a. So get your negative 2 to a 0 by adding 2. And that's 18. So over here we got negative 3 times absolute value x plus 4. Now we still have the a value. We do not distribute the a value, we divide it so it cancels. Okay, so I have the absolute value of x plus 4, and then negative 18 divided by negative 3 is negative 6. Now again, this is a no solution because we can't have the absolute value equal to a negative, so that's no solution. We don't even go to our table if it's no solution. Okay, next problem. 4, absolute value of x minus 4 plus 7 equals 27. So within the absolute value, I have the expression x minus 4. Now what do you have going on outside? The 27 doesn't matter, it's on the other side of the wall. Okay. Well, I've got a times 4, that's an a, and that's a k. Okay. So you need to get your plus 7 to 0. You need to first do the k, get that to 0, then you're going to divide by your a. So minus 7, minus 7. Now I'm at 20. But I've still got 4 times the absolute value of x minus 4. Still got that A there. Do not distribute the A, and you don't add or subtract the A. You always will be dividing by the A. That cancels, and now I have just x minus 4 in the absolute value. Then 20 divided by 4 is 5. So I can be 5. This has a solution because you're at a positive. You can be a positive 5 from 0 here or here. So it'd be 5 and negative 5. Okay, wall, 1 dot circle. So that's a negative 4 out there, so you plus 4. 5 plus 4 is 9, 1 dot x. Then I divide by 1, x equals 9. Okay, 1 circle plus negative 4. Now I do the same exact thing, but now this changes over here because it's negative 5 plus 4. So instead of going 5 plus 4, we start back at negative 5 and plus 4. 1, 2, 3, 4. So that's going to be negative 1. Then I divide by 1. Negative 1 divided by 1 is negative 1. Okay. So 9 and negative 1 are my two solutions for that. Okay, next problem. 5 absolute value of x equals 20. So within our absolute value, we have just x. Easy enough. But there's a number outside the absolute value. It's in front, means times, and that's an a value. So we underline each side of the wall and just place a 5 underneath. So we have absolute value of x. 20 divided by 5 is 4. So to be 4 places from 0, we'd be at 4 or negative 4. And then the problem's pretty well solved. The x is already by itself. Okay, then the last problem. Negative 2, absolute value 3x plus 6, plus 6 outside equals negative 66. Now what a lot of people do, they see the negative over there and think it's a no solution. We don't know that yet because we have operations outside, an a and a k. So we got 3x plus 6, 3x plus 6. So the front is an a, that's a multiplying number. And here's a k. We have to get rid of k first, followed by a. So the k I just get to a 0. Since the k isn't multiplied by anything, I'm thinking get it to 0. So minus 6, minus 6. Negative 66 minus 6 is negative 72. Then over here I've still got negative 2 times absolute value of 3x plus 6. So the k is gone, but what about the a? Do not distribute. You also don't plus 2. A multiplying number means we divide by negative 2. Okay, so absolute value of 3x plus 6. Negative 72 divided by negative 2 is 36. So we're 36 places from 0. Well, I could be at positive 36, or I could be back the other way at negative 36. So wall dot circle. So we subtract 6. 36 minus 6 is 30. 3 dot x. Then we divide by 3. 30 divided by 3 is 10. Okay. Meanwhile, on the other side, 3 times x plus 6 equals negative 36, so we take away the 6, minus it because it's positive. This time, remember, if you're using a calculator, you don't go 36 minus 6, you go negative 36 minus 6, which takes us to negative 42. Negative 42. Then we divide each side by 3. And then negative 42 divided by 3 is negative 14. Those are the two answers.